All right, first one. An infectious flu virus is spreading through a school. The probability of randomly selected student having the flu next week is 30%. So the first question asks, what's the most likely number of students out next week in a class of 24? So most of you guys set up the binomial distribution for that. So binomial dist, and then how many trials was it? It was 24 trials because there were 24 students, and then the probability, I don't put the number 30, what do I put? 0.3 or 0.30, yep. Okay. All right, and then I like to pick the zoom fit so that I can see the picture better, and then I can click on the highest point, and it tells me it's most likely that 7 students will be out. And the probability, instead of writing 0.176, I write what percent? 17.6%. Very good. Okay. So let's go back here. Calculate the probability that 2 or more students in a class of 24 will have the flu next week. So we go back to Desmos and check the find cumulative probability. And we want 2 or more, so that's 2 to 24. And you've got 0.997. We're going to round that to 99.8%. All right. Next one. If more than 20% of the class of 24 have the flu next week, the class test will be canceled. What is the probability that the test is canceled? So when you did 20% of 24, you got how many people? 4.8 people. And it has to be more than 4.8 people. So you started with a min of what? Good. A min of 5 and still a max of 24. So let's check that one and see how you did. Min of 5 and max of 24. So I'm getting 88.9%. Does anybody have a question on the rounding there? It does say to do 3 significant digits, but I didn't even notice that at the beginning, and I was doing 4. Doing too many digits doesn't bother me, but doing too few does. So I would take 88.9, or I would take 88.89%. Okay, questions on that one? All right, the second one was really very similar. 86% of households own a cellular phone, random sample of 10 households. What's the probability that at least 8 own a cellular phone? All right, let's see. So this time for my binomial distribution, how many trials were there? 10 trials, very good. And it was 86%, so I'll put 0.86. And I need at least 8, so that would be, is 8 the min or the max? The min, good. Okay, so I'm getting 84.5%. Is that what you guys got? Mm-hmm. All right, and then fewer than 8. A lot of you guys asked me to clarify that. I am not trying to trick you with words. I don't think there's something tricky on the check-in, but if there is, you can say, does that mean including 8 or not including 8? Okay, it's fine to ask me that. So in this case, it does not include 8, right? So what's your min going to be? Fewer than 8. The max. Okay, good. So 0 to 7. Good. And I'm getting 15.5%. Is that what you guys got? Okay. And notice that those two probabilities, they add up to 100%. Because it's either going to be at least 8 or fewer than 8. So those two should add up to 100%. The number of households owning a cellular phone is between 5 and 8 inclusive. So this time you had to go back to your Desmos and do 5 to 8. So I'm getting 41.7%. Is that okay? Okay, and for the expected number of households, you actually did not need to use the binomial distribution. I just needed to find 86% of 10, right? Which is 8.6, right? Now for expected value, even though the number doesn't make sense, you're still allowed to use the decimal because you're going to translate it into larger numbers. So the expected value is 0.86 times 10, which is 8.6. All right, any questions on the front?
Yeah, how did you get 15.5 for me?
So fewer than 8 on a cellular phone did not include the 8, so we did 0 to 7. So I'm going to show you again here, 0 to 7.
That's why your answer is different. It says fewer than 8.
Okay, other questions before we go to the back?
Do you understand how she got Z to do that in different huh?
Okay. When I was a kid, I used to love the duck pond game because it was so easy and you always won something, right? So the carnival has a duck pond game. 20 ducks are numbered 1 to 20 and it costs $5 to play. If you choose a duck numbered 1 to 10, you win a small prize worth $1. If you choose a duck numbered 11 to 18, you get a medium prize worth $5. And if you choose a duck numbered 19 or 20, you win a large prize worth $20. So the expected or the outcome earnings, you could win $1 or what else? Or 5 or 20, good. So the extra line, we didn't need it. All right, how many ducks are numbered to get $1? There are 10 ducks out of 20, which is 50% or 0.5. I'm going to use 0.5 right now because it's going to be helpful in that form, but 50% is also right. So 10 out of 20. And then for the $5, how many ducks were numbered to win $5? How many? 8 of them out of 20. So 8 out of 20 gives us what percent? 44 or 40? It's 40, right? Okay. So that's going to be 0.4. Oh, you guys were saying 0.4. I get you now. Thank you. All right, and then how many ducks could win you $20? 2 out of 20, which is 0.1. Now, just as a check, your probabilities should add up to 1 or 100%, and they do. So that's good. So we had 50%, 40%, and 10%. To find the expected value, you multiply the outcome times the probability, but in the end, you have to subtract the cost of playing the game.
So what is the expected value of the value? This is the next question.
All right, so we've got $1 times 0.1, oh, sorry, it was 0.5, my bad. $1 times 0.5 plus $5 times 0.4 plus $20 times 0.1. All right, and you can either subtract in this step or you can subtract in the later step. I've kind of got a mess over here, so I'll subtract in a minute. So that's giving me 0.5 plus 2 plus 2. So I'm getting 4.5. Is that what you guys got? Okay. So I'm getting $4.50 you would win, except that you paid $5. So overall, what are you losing? You lose 50 cents. So we had $4.50 that you would expect to win. Subtract out the $5 that you paid. So the expected value is negative 50 cents. All right, the last one is complicated. I don't believe there's anything this difficult on your check-in, but it's still good because it will prepare you. All right, Elena plays a game where she tosses 2 dice. If the sum is 6, she wins 3 points. If the sum is greater than 6, she wins 1 point. And if the sum is less than 6, she loses K points. It doesn't tell you. Find the value of K for which Elena's expected number of points is 0. So we can make like a little outcomes chart just like this one. So we have X and we have probability of X. All right, so it would be 3 points, 1 point. Oh, that does not look like a T. And K points. All right, so if you consider the chart that I made of when you roll 2 dice, which is on the right board, and you consider the sums, how many ways are there to add up to 6? I heard one answer of 5, 2 answers of 5. So there are 5 ways to get a sum of 6 out of how many possibilities when you roll 2 dice? 36 possibilities. If the sum is greater than 6, she wins 1 point. So considering the chart, how many are greater than 6? I heard a 21. Can anybody confirm 21? Okay, so 21 are greater than 6. So I'm going to do 21 out of 36. And then that leaves how many that are less than 6? How many? 10? So 10 out of 36. Okay, so there's no paying in this game. Did you guys get that? So you just want the expected number of points to be 0. That means that K has to be what kind of number? A negative number, yeah, because we already have 2 positive outcomes, and we don't have any negative outcomes to balance those out. We want it to equal 0. So we do know it's going to be negative. That does not actually help us find it. It's just a prediction. So we're going to add them up. So we have x times the probability of x. So I have 3 times 5 over 36 plus 1 times 21 over 36 plus k times 10 over 36. And we want that sum to be 0. It's a zero-sum game. All right, so luckily Desmos can do your fraction work for you. I'm going to leave that up for just 1 minute because I know some of you are still getting that. And then we'll look at Desmos. Okay.
No, Jaws is not.
Okay, so when I do this, I am seeing that if I add my first 2 together, I get 1. Anybody else find that? That was convenient. So I have 1 plus k times 10 over 36 equals 0. And I can subtract 1 from both sides so that I'm trying to isolate the k. So I get negative 1. And this is just a little bit of algebra. If I have k times 10 over 36 equals negative 1, what is one strategy for isolating that k? I could divide by 10 over 36. That's good. Did anybody have a different strategy? Did anybody multiply by the reciprocal? It's also a possibility, but if you guys like Kenneth's strategy, we can do that. We're going to divide both sides by 10 over 36. I would recommend using parentheses on that 10 over 36 to hold it together. All right. So I'm going to take a minute now and do that calculation. Negative 1 divided by, and then in parentheses, 10 over 36. And then close those parentheses, and I get negative 3.6. Did you guys get that? All right, so k has to equal negative 3.6. Yes.
Slightly more of a grammatical question, but would it have to be a positive 3.6? If she loses negative points, that's gaining.
Let's see. Find the value of k for which Elena's expected number of points is 0.
Yeah, and then
So does she lose?
above that,
Yeah,
if the sum is less than 6, she loses k points.
I get you. Okay. if you explained that to me in a sentence and you put positive 3.6, I would be with you because I do believe that you're right about that grammar there. Any other questions? Okay, I do want to give you guys lots of time for this check-in, so I'm going to ask you to set aside your phones. They can go in pockets or they can go into backpacks.